Hello everyone. So now again we have to integrate this function using cylindrical coordinates, and S is a region which is bounded by plane z equal to 3 and cone z is equal to x square root x square plus y square. So step 1, we try to find the region. So S is bounded by z is equal to 3 and z is equal to square root x square plus y square. Right, so this is an equation of a cone, so we will try to plot it first. So we have our xy plane, right? So this is my x, this is my y, this is my z, and we have a cone of this form. Okay, so this is the required cone. If we see, so this is z is equal to the positive square root x square plus y square. So since we are considering the upper side, so it will be a positive square root, and then we have a plane z is equal to 3. That means this will keep growing, but we will cut this will keep growing, but we will cut it at the plane z is equal to 3, right? So now I have to take cylindrical coordinates. That means I have to take a cylinder that will enclose this region. So I will consider something like this, a cylinder which is tightly bounding, something like this on both sides. Okay, so my imaginary cylinder is this. All right, so this is my imaginary cylinder that encloses the region. One region is cone and other is this plane z is equal to 3. All right, so for determining the radius of this cylinder, we will check this. So at this plane, the cone and the plane and the cone intersect. So if I put z is equal to 3, that is also equal to square root of x square plus y square. That means my x square plus y square is actually 3 square. So this cylinder which I am taking which will be having a base like a circle, and the circle is nothing but actually the base is a circle with radius 3. This is the base of the cylinder which I will consider. Alright, so now we need to put the cylindrical coordinates. So put x is equal to r cos theta, y is equal to r sin theta, z is equal to z, the Jacobian of the transformation, that is r. And now for finding the limits, we have to see the geometry of the region. So we know we are considering a circle of radius 3. So we will take 0 less than r less than 3, 0 less than theta less than or equal to 2 pi. And for finding the z limit, what we are supposed to do here is we will take a strip which is parallel to z axis. Okay, so one end of the strip is resting on the plane and the other end of the strip is, the lower end is touching the parabola, sorry, the cone, and the upper end is touching the circle. Okay, so here the lower end of the strip is z is equal to square root of x square plus y square, and when we put x is equal to r cos theta, for x is equal to r cos theta, y equal to r sin theta, so z will be nothing but square root of r square or simply r. Okay, so the lower end is of z is r less than or equal to z, and the upper end of z is nothing but on the plane. So the strip is moving like this. Okay, so we can see the lower end of the strip is always on the cone and the upper end of the strip is always on the plane. So g r less than or equal to 3, right? So this is our region, this is our limit. Now we will try to integrate our function. So we can see here, so we use our coordinate system now. So triple integration s square root of x square plus y square plus z square dx dy dz. This I will now convert it into square root of square root. So integral of x square plus y square is r square plus z square. For simplicity I will take 0 to 2 pi. That means theta I will take first. Then I will take dz. So z is from 3 to, if we see, z was from 3 r to 3. So that means it will be from r to 3, So I'm taking z because z is depending on r, and the last is r is the radius is from 0 to 3, and without fail we have to multiply by the Jacobian. Alright, so this is our conversion now. The next step is we will integrate one by one. So first integral is theta. So this converts to 0 to 3 r to 3 square root of r square plus z square multiplied by r, and then this will become integration 0 to 2 pi d theta dz dr, right? So this integral is now nothing but 2 pi if we see. So 0 to 3 r to 3 r square root r square plus z square theta 0 to 2 pi dz dr. Alright, or simply 2 pi integration 0 to 3 r to 3 r square root of a r square plus z square dz dr. Alright, so now the trick here is, if I try to integrate this is quite complicated if we see, but what we can do, we can convert everything by we can convert the region first to simplify the thing. So this with respect to z actually goes into log and all, this integration. So I will try to change the limits. I will try to interchange them. So I will try to first plot them. So let's call this as star. Now if we try to check the region, here the limits for z is from r to 3. So 0 less than z less than 3. And limit for r is from 0 to 3. Alright, so I will just try to find this integration. So let's try to plot it. So this is say z, this is say r. So this is sorry, the limit for z was from r. So this is z is equal to r, okay, and z is equal to 3, and limit for y is from y equal to 0 to y equal to 3. That means we are considering this region for integration. And if we see from here, the first integral is z. That means the strip is parallel to z axis. This is our old strip. Okay, so the new strip will be perpendicular, and that will be parallel to our axis. Now we can see that the limit for this on z axis is between 0 and 3. So 0 less than z less than 3, and the limit for y for r, this is r equal to 0 and r equal to z. So 0 less than r less than or equal to z. Alright. So therefore this integral which we had, so therefore 0 to 3 r to 3 r square root r square plus z square dz dr, that is what we had, r to 3 0 to 3 r dz dr. So that will be now equal to integration 0 to 3 and 0 to z r square root of r square plus z square dr dz. Okay, so then it becomes more easy because solving this is quite complicated. So I am trying to simplify by changing the order of integration. Alright, so now what I will do, put r square plus z square as t. That would imply r dr is dt by 2, and I have to change the limits also. So as we can see, r is going to 0, r goes to 0 implies t will go to, if I put 0 over here, so that is 0 plus z square, which is z square. Alright, and the upper limit is 0 z. So when r goes to z, that would imply t will go to z square plus z square, that is 2z square. Okay, so we will get integration 0 to 3 integration z square to 2z square, and this will become square root of t. This part will become square root of t. Dr will become dt by 2. rdr will become dt by 2, and dz as it is. Alright, so I'll take 1 by 2 out. Integration 0 to 3. This integral will become t raised to 3 by 2 upon 3 by 2 from z square to 2z square dz. Alright, so this I can take out. So this is half into 2 by 3 and integration 0 to 3, upper limit minus lower limit. So 2z square raised to 3 by 2 minus z square raised to 3 by 2 dz. Alright, so simplifying this further, that will be like 1 by 3 integration 0 to 3. This becomes 2 raised to 3 by 2 multiplied by z square 3 by 2 is nothing but z cube minus this will become z cube again dz. Alright, so this is nothing but, if I see 2 by 2 raised to 3 by 2 minus 1 is constant. So finally I will get 2 root 2 minus 1 by 3 and then integration 0 to 3 z cube dz. Alright, so finally we are left with, if we calculate this, it is equal to 2 root 2 minus 1 by 3 and that becomes z raised to 4 by 4, 0 to 3, right? So that is 2 root 2 minus 1 by 3 into this becomes 3 raised to 4 by 4 and cancelling this 3 is 27, 2 root 2 minus 1 by 4. So this is our answer for the integral part, if we see, right? But so we can substitute in star. So finally this will be, the final answer will be equal to, so final answer is 2 pi multiplied by 27, 2 root 2 minus 1 by 4, or simply 27, 2 root 2 minus 1 by 2 multiplied by pi. Alright, so the idea is pretty simple. Just solve this interior part, okay, by reversing the limit. Thank you.